Okay, this is our presentation. We will be doing a CFD simulation for oxygen flow through an oxygen lance. My name is Austin.
I'm Tyler.
I'm Liam.
I'm Dylan.
And our project is sponsored by Barukyah Metal Company. Just some simple background for the steelmaking process. You're going to put iron into the blast furnace that is then going to get chemically reduced into molten pig iron with a high carbon content. This then will get moved into the basic oxygen furnace where we have our oxygen lance, and this will spit oxygen out into the molten bath in order to take out the impurities from that molten pig iron, which then will give you refined molten steel.
For our project, we're focusing on looking into the basic oxygen furnace. As Austin said, this is a primary process for refining the molten steel. After the pure oxygen is injected into the molten iron, it reacts with the reacts and produces carbon dioxide and carbon monoxide, which have to be filtered out through the furnace. And this is what enables the steel making at high efficiency and getting good quality steel. Even more in depth, we're focusing on the oxygen lance, which is boxed in the red box there. It delivers a high velocity stream of pure oxygen, and it can affect the quality of the steel that is produced based on the reaction efficiency and the operation time in the furnace. The top adapter is how it gets secured to the mounting of the basic oxygen furnace. And for ours, we are not going to have a distributor on either of the designs that we're focusing on, so we will not be looking into that for our project. Our main point that we're looking into is the lance tip, and we were given two different geometries, the standard tip and the cyclone tip.
So this is just an example of how the lance works. So you have oxygen flowing through the center, and then you have cooling water running through a channel to keep the temperature down for the tip and the whole lance. And these are just overall dimensions. So Very Metal gave us their spreadsheet that calculates a bunch of parameters that are necessary for designing these oxygen lances. So you put in different input parameters. Say they want this size of lance or this Mach velocity, and then it can calculate the other parameters that need to be included in the design to achieve those outputs. And then so you can get the nozzle design, and then off of that design you can get impact area and the depth of penetration, which are geometric measurements based on how that oxygen lance interacts with the molten bath.
Our project's problem statement is to develop a CFD model to evaluate oxygen lance parameters for validation and refinement of the spreadsheet. In order to accomplish this, we performed various background research, we broke down the spreadsheet, and we performed many simulations involving CFD simulations as well as FEA simulations. And we also performed a lot of hand calcs to validate our simulations as well as the spreadsheet. Thank you.
Yeah, thank you guys.